In this video, we'll be using relative formula mass to calculate the percentage composition of elements in compounds. For example, what's the percentage of carbon in carbon dioxide? We'll also be calculating percentage yields, which is 1.3, and we'll be calculating which substances are in excess and which substances are the limiting reagent. The first question, we're going to use relative formula mass to find out the percentage, to find the mass of nitrogen in ammonium nitrate. To do this, we need to find out the mass of ammonium nitrate first, and we look at the periodic table and we look at the top number, or the mass number of each atom, and then we add them all up and multiply by how many atoms are in the molecules. So nitrogen is 14 if we look in the periodic table. Hydrogen is 1, but we have 4 of those. And we have another nitrogen, which is 14 plus 16, and we've got times that by 3 because there's 3 of them. Now, you're going to get 80 as the mass of ammonium nitrate. Now, once you've got the mass of ammonium nitrate, you now need to work out what's the mass of nitrogen in ammonium nitrate. Now, you've got to look at you've got to find out how many nitrogen atoms there are. So there are 2, so we've got to do 14 times 2. That's going to give us the mass of our nitrogen. That is going to be 28. Now, if we want to work out the percentage of our nitrogen in our ammonium nitrate, we've got to divide these two numbers. So we've got to divide 28 by 80, and then we've got to times it by 100 to turn it to a percentage. Now, doing that, you should get 35. So we should get 35 point. No, so just 35%, sorry. Just 35%. So it's 35% nitrogen in ammonium nitrate. The second one, we do exactly the same thing. So the mass of sulfur in aluminium sulfate, sorry. And so we look in the periodic table, look at the mass numbers, and we do 27 times 2, plus then we work out the mass of the sulfate molecule. Sulfur is 32 plus our 16 of oxygen, but we've got times that by 4. Then we've got times the sulfate molecule by 3 because we've got 3 outside the brackets there. Now you can just put this in the calculator exactly how I've typed it there. It will work, and it's a lot easier there. You will get 342 there. Now you need to know the mass of sulfur in aluminium sulfate. So there is 32. That's sulfur times by 3. Then once you've got that answer, you can just divide it, do exactly what you've done before. So 32 times 3 divided by 3 divided by 342, and that's going to equal 28.1%. So there's 28.1% sulfur in aluminium sulfate. Okay, now you're going to give it a try. Spend 4 minutes on this, pause the video now, and you'll get your corrections after. Okay, these are your answers. I just wanted to highlight question 13 because it can be quite difficult. Now, they've times the oxygen by 9 because there are 9 oxygens in here. There's 5 here because you've got 5 water molecules. Then there's 4 here because you've got small 4 there, and it's the same with this with the oxygen in question 11. You've got 2 of those, you've got times it by 2. The same with the chromium, you've got 2 of those, you've got times it by 2. Okay, now we're going to be calculating the percentage yield, and I've got a question here for you, and this is a 2-step question. The first part of the question is exactly what we did before in the last video. We'll be calculating the mass of a mass that can be formed using the moles equation. So I would always lay it out like this. This is a good template to do, and you won't go far from the track if you lay it out like this. So the first step in here is to complete this table. And once we complete this table, or the parts that we need, we're going to get our answer. So the first thing I'll do is insert the information that you get from the question. So it says calculate the mass of iron. So that's what we want to know. I'll put a question mark there. That can be formed from 126 grams of iron oxide. So we'll put 126 grams in there. We can go straight in there. And then we need to calculate the MR of iron oxide, and we do that doing the exact. We find out the mass number of each atom, and we add them up. We add up how many atoms. We add them up and multiply them by how many atoms there are in that molecule. So it's 56 times 2 plus 16 times 3, because it's 3 oxygens, and then that equals 160. Now to work out the moles, we can use the equation which you should know at your head, which is moles equals mass over MR or AR, and it's MR in this case because we're talking about molecules, not atoms. So we do 126 divided by 160. Now I'm just going to leave it in that format. I'm not going to work it out. There's no need to. So the next step, we now need to work out the ratio that these atoms and molecules react and form in. So our molecule of iron oxide, so one molecule of iron oxide. Now I've got that number from this number in front. There's no number. That means there's one molecule of iron oxide will react to form 2 atoms of iron. So the ratio here is 1 to 2. Okay, and once we've got that ratio, we can then multiply that by we can then use that to find how many moles of iron are going to be produced. So that's going to be, we're going to form double the number of moles we had. So we need to times that by 2. So we're going to form double the number of moles of iron oxide that we have, and that's going to equal 1.575. Okay. Once we've got that now, we need to work out the MR of, or we need to find the MR of iron. We could just get that from the periodic table. It's 56. We already knew it from before. And then to work out the mass, we just need to rearrange our equation there. We need to bring MR to the other side. We change its sign, which it goes from divide MR to times MR. So we have a new equation is moles times MR is equal to mass. So we have to multiply these two numbers basically. So 1.575 times 56 is going to equal our mass, which when you type it in the calculator is 88.2 grams. Yes, it's 88.2 grams, and that seems about right. That sounds reasonable. If we start off with 126 grams, we're going to end up with 88 grams of iron. It sounds reasonable, and we expect it to go down. Okay, so I'm guessing that's right. And now for the next part where we're calculating percentage yield, what you need to know is that when reactions happen in real life, we never get the expected yield, the yield that we expect, or the yield that we've theoretically calculated. That never happens, and that's because of these reasons here, which you'll need to know for your exam. So to calculate the actual yield that we get, we do want as close to 100 as possible. We have to take this value, so the actual value that we got, that's 78.5, and we need to divide it by the maximum amount that we can theoretically get, and that's 88.2. Okay, and then to turn that into a percentage, so now it's a fraction, we need to turn it to a percentage. We just times that by 100, and times it by 100, we get 89%, and that sounds about right. We have our yield is 89%. It's not 100%. If it was 100%, this number would be 88.2 as well. But that's not going to happen because of these four reasons here, which I've put in the corner there for you. Okay, here's another example. We'll do the exact same again. I'll go through the whole procedure exactly the same, and then I'll leave you guys to get on with it. So we first write out this table. Now again, you don't need to write out the whole table, but I do just for good practice, but you don't need to. So first we put in the information that we get from the question. So this is calculate the mass of chlorine. So we're looking at the chlorine here, and that's here. So the mass of chlorine, we're going to put that there. That can be formed from 50 grams of sodium chloride. That is here. So 50 grams of sodium chloride. In the last video I put grams in the box, but it should actually be here. So we've got 50 grams of sodium chloride. So the first thing we need to do is work out the MR, and that's easy peasy. It's 23 plus 35.5. That's going to equal 58.5. And then from those two values, you can work out the number of moles. So you just need to use the equation moles equals mass over MR, and that's why I've laid it out like this, but moles equals mass over mR, so we have 50 divided by 58.5, and I'm not even going to calculate that, there's no point just yet. Then we can just leave it as a fraction. Then we work out the ratios. So we have 2 sodium chloride, I was going to say molecules, but sodium chloride isn't a molecule, but 2 sodium chloride formulas react to form form 1 chloride molecule. Okay, so then now we can work out the moles. So if we have 2 moles of this, we're going to have half as many. We're going to have half as many on the other side. Okay, so we need to divide this number by 2. So we need to do 50 over 5, 58.5. We need to divide that by 2. Divide that by 2. We'll just divide by 2. And that's going to equal 0.427. Now, once you've got that, you can now work out the MR to work out the mass at the end. Now, the MR here, you actually have to work out the MR of the whole molecule. So we've got 35.5 times 2, that equals 71. Now, you have to do the whole molecule because you haven't taken into account that 2, because you're working out the weight of this molecule, the mass of this molecule. So we've got 71, and then to work out these two, we just times them together, what we did in the previous. So 0.427 times 71, and then you're going to get 30.3. Now that sounds about right. You get 50 grams of sodium chloride. That's going to react to form 30.3 grams of chlorine. That sounds about right. So I think we're onto the right tracks there. So let's go to our part B, which is the one that we really wanted to get to. So we've got 25 grams of chlorine was formed in this reaction. So this 30.3 is the maximum possible mass we can get. But actually, when we did this reaction in the labs, we only got 25 grams. So to put this as a fraction, the bottom number is always heavier, always bigger. So we've got it in a fraction. To turn it into a percentage, we just times it by 100. And that's going to equal 82.4%. That is the yield of this reaction. That's how much we yielded out of the theoretical value, 82.4%. Let's say give yourself 4 minutes to answer this A and B, both these questions. Here's some help for you. Pause the video now. Okay, here are your answers. You should have got those and this. Again, I'd say to give yourself about, this time 5 minutes. I've given some help there. I've given you a table. Go. Okay, so you should have got these answers. You could have had any 3 from the below. Okay, again, give yourself 4 minutes. Pause. These are your answers. In this question, we're going to be calculating which reagent is in excess, and so which reagent do we have enough of, or more than enough, and which reagent is limiting the reaction. So which reagent do we not have enough of? So this question is, we're going to lay out exactly how we have done before. And this question just asks us to calculate the mass of calcium hydroxide. So what mass of calcium hydroxide is formed when 10 grams of calcium oxide reacts with 10 grams of water. So we just do exactly the same as what we've been doing before. We calculate the MR of calcium oxide first, so that's 40 plus 16, that equals 56. Then we can work out the moles from there using our equation. Moles equals mass over MR, and that's going to equal 10 over 56. That equals 0.179. And then again, we do the same thing for water. MR of water is 18. and then divide those to get the moles at 0.556. Okay, so we look at the ratio. So we have one molecule. So we look at the ratios. We look at the numbers in front. We've got this is a 1-to-1 ratio. So one molecule of calcium oxide reacts to form one molecule of water to produce one molecule of calcium hydroxide. So 1-to-1 ratio. And if we look at calcium oxide first, if we have 0.179 moles of calcium oxide, that's going to react with 0.179 moles of water. But we actually don't have that. We don't have that value. We have a different. We actually have more water than what is needed in this reaction. So we can say that the reagent in excess, reagent just being a substance, it's just a substance really, just a substance involved in a reaction. Substance involved in a reaction is a reagent. So a reagent in excess is water. We've got more than enough. The limiting reagent, one that's limiting reaction, is calcium oxide. Okay, so we can now from this work out the moles of calcium hydroxide that's going to be produced. It's going to be 0.179. We can't form any more than that because we just don't have enough calcium oxide molecules to form this calcium hydroxide. So from there, we can work out the MR. We need to work out the MR of this. So we've got calcium 40 plus 16 plus 1 times that by 2 equals 74. Then again, rearranging this equation, MR times moles equals mass. We just times those two numbers, what you've been doing before. So when you times those two numbers, you get 13.2. Okay, we'll do one more. Again, we use the same formula. It says what mass of iron. So we're looking for iron. What mass of iron? I've got a question mark there. Is 4.8. Sorry, question mark there. And it says when 8 grams of iron oxide, so we've got 8 grams, reacts with 2.16 grams of aluminium. So again, we do the MR, so we do 56. We find the MR of iron oxide is 56 times by 2 plus 16 times by 3. You're going to get, if you can remember from the last equation, it's about 160. So we get 160. Then to work out the moles, we do mass divided by MR. That's 8 divided by 160. That's going to give you 0.05 moles. And then we can now work out the moles of aluminium. So your MR for aluminium is 27. Working out moles equals mass divided by MR, 2.16 divided by 27. That's going to equal 0.08. Okay, now we can look at the ratio. So we look at the numbers in front of here. 1 molecule of iron oxide reacts to form 2 molecules of aluminium oxide. So if we have 0.05 moles of iron oxide, that's going to react with that can react with a maximum of 0.1 moles of aluminium. But we actually have 0.08, so we have less aluminium than is needed to react with all of our iron oxides. So we have less than is needed. So our limiting reagent even is going to be aluminium, and our reactant in excess is going to be our iron oxide. There's more of it than we need. Now we can now use the values for the limiting factor, and that is aluminium. So the moles, so 2 moles of aluminium reacts to form 2 moles of iron as well. So the ratio is the same here. So we're going to get 0.08 moles of iron. Now the MR is 56, and then to work out the mass, we just times these two numbers together. 0.8 times 56 times 56, and we're going to get the mass, which is 4.48 grams. Now that sounds about right. Okay, I'm going to leave you guys to get started. Spend around 4 minutes, give this a try and lay it out exactly like this. Okay, here are your answers. Next one, exactly the same. Give yourself around 4 minutes and lay it out like this. Okay, here are the answers. Again, this is quite simple because you just have a 1-to-1 ratio, so very simple. Question 4 again, give yourself 4 minutes. Use this as a structure. More trickier because you have 2-to-1-to-2 ratio. This means that you're going to have to do a bit of math here. So when you have, with sodium, you have 0.1 moles, and in a 2-to-1 ratio, this means that 0.1 moles of sodium could react with 0.05 moles of fluorine, but actually we have 0.75, so we have more than what is needed. So your fluorine is in excess, sodium is limiting the reaction. So you always have to use your limiting, the moles of the limiting reaction. You always have to use that when working out the moles of the product formed. Again, give yourself around 4 minutes. This one's a bit more tricky because we've got 2-3-2 ratio here, but it's exactly the same what you did in the last one. Your answers are here. So again, you have to look at the first moles and then see how many moles that can produce of the other reactant or reagent. So if we have aluminium 0.5 and we have 2 moles of aluminium, it will react with 3 moles of chlorine. That means if we have 0.5 moles of aluminium, it will react with 0.75 moles of chlorine at a maximum, but we don't have enough of chlorine. We don't have that. It's not. So that means our chlorine is limiting the reaction. So the limiting reagent is chlorine. Our reagent in excess is aluminium. Therefore, we use this value when calculating this value. So if you have 3 moles of chlorine, that's going to react with 2 moles of aluminium chloride. So the ratio is 3-to-2. So you get 0.4 moles of aluminium chloride, and therefore you can work out the mass after that.